or night 1 and night 2. We're going to answer questions. Also, I need to remind you, what starts today?
10% off each day.
10% off. Now, when I say each day, that's each period. Okay, so like each of this period, you know, like, so it's technically every other day, but you get the idea. Yeah, anytime after this, yeah. Okay. Alrighty, so everybody give Brickell a big round of applause. Charlie's not here. Right. Anytime you get a chance to win a state title, they don't come around very often. Alrighty, so it is 3 and Dale About's mom. So good job. Okay. Not sure if you had any part in that, but you have to live with her. So, you know, during the season can be kind of rough. My boys went through it. Alrighty, so it is the 8th today, and this is obviously 5th period, and this is going to be questions 9.1 and 9.2. What do we got? Murray, you like sending a text right in front of me?
Me?
Yeah.
I'm trying to take a picture of my assignment because it wouldn't submit.
Oh, yeah, and I'm not going to buy that anymore.
I submitted mine at
I'm just telling you, it better be submitted before class starts.
It's not this one, it's another one.
Oh,
Like
well,
I submitted,
I'm just saying,
free, but
I've heard that excuse like 70 billion times.
Yeah.
This year. I mean, you know what I'm saying, right?
Yeah.
Alrighty, so questions 9.1 and 9.2. Anybody? Yo.
For 9.2, if the x is in the denominator, did you have to like make it not in the denominator?
So you had to find x. It's like use a Pythagorean theorem or something. You see what I'm saying?
Yeah.
Okay. Now, there is one thing I didn't teach. I completely forgot.
Was it the finding the distance?
Yeah, distance formulas.
Isn't that just finding slope?
No, that's slope. Anybody know the distance formula?
Is it y minus y2?
No, that's slope. Its distance is equal to the square root of nobody? No.
MC squared.
No, I believe that's E equals MC squared. Nobody's ever seen the distance formula? No? Oh, good job, Us. You saw that. What do you got for me?
Y in parentheses y2 minus y1 to the second power
Squared.
plus x2 minus x1. I remember this.
Yeah, I don't know. I didn't even think about it. So if I had you know, the point 7 and 2 and the point -3, 4, and I wanted you to find the distance between those 2 points, you would first do what? Anybody know? Okay, first thing you want to do is you want to label your points. So like 7 would be my x1, right? Well, if 7 is my x1, what does that 2 have to be? It has to be y1. I can't tell you how many students will go x1 and x2. Yeah, just not paying attention. So what would my -3 be? x2 and 4 is my y2, right? Then it just becomes substitute and simplify. So I'm going to get the square root of y2 minus y1. Well, that's going to be 4 minus 2 squared, right? Plus x2 minus x1, which is -3 minus 7 squared, right? That's getting me the square root of 4 minus 2 is 2 squared is 4 plus a -3 minus 7 is negative what? -10 squared is 100, and that's going to give me the square root of 104. Then what do I do here? Yeah, I make sure, see if I can move that, right? That is, I don't know, 2 roots of 26. Our x isn't 104. 4 times 26. 26 is 2 times 13. They're prime. 4 comes out as a 2. I think that's the answer. Oh, you mean up? Something like that. And there's like 4 of those. I don't know. I wasn't even thinking. Okay, how about 9-2? Anything on the trig ratios? Number 6? Because you had to solve for x first.
Yeah.
Well, let's look at it. So 6 says, got this, got this, I got 16, I got 30, and I got x, right? So I'm going to go 16 squared plus 30 squared equals x squared, right? So I got 900 plus 256, right? Gives me 1156. Got a square root of 1156. Who? Anybody do this?
34.
You get what? 34? Yeah?
Maybe I did it wrong. Yeah, I definitely did it.
Is that right?
Yeah.
Yeah? So then I'm just going to go, and I'm going to go, and it wants the sine. So I got K, L, M. So I want the sine of M. Well, sine is opposite over hypotenuse. That's going to be 16 over 34. But if I leave that as my answer, what's going to happen?
It's gonna be wrong.
Yeah, it's going to be wrong. It's really going to be what? 8 over 17, right? Okay, and then it wants the cosine of M. Cosine of M, that's going to be 30 over 34, but that's really, what, 15 over 17, right? And then it wants the tangent of K. Well, here's K, tangent's opposite over adjacent, so that's going to be 30 over 16, which is, I don't know, 15 over 8? 15 over 8, something like that. Anybody else get those answers? That's it? Only 2 of you? How many of you got those answers? Raise your hand. That's better. Does that make sense, Bruce? What'd you do wrong?
I just square rooted it wrong. Maybe I put in the wrong number or something.
I did these in my head. Is this what?
Yeah.
Is that what you got, Palmer?
I used to calculate.
Oh, okay.
Same thing.
Alrighty. So if you do not have a calculator, you need to make sure you have a calculator for today. I'm really smart and I can't do this stuff in my head. So, you know, just saying, you need to have a calculator.
Never mind, I want my phone back.
Alrighty, so what we're going to do, okay, and I should have your test gone through by tonight, so if you wanted to do test correction, you'd be able to do so. Our objective for Unit 9.3 is going to be to be able to use the trig ratios to solve for the sides of a triangle. Now, this is what's going to happen. They're going to give you some kind of triangle. Now, we already know that it must be a what? Yeah, it's got to be a right triangle, right? They're going to say that, let's say that this is 12, this is x, this is y, and let's say that this is 40 degrees, okay? Now, what they're going to do, and let's say that this is z right there, z degrees, right? They're going to eventually, and this is more for the test rather than just section 9.3, they're going to simply say to solve the triangle. Okay, what that means is you need to find out everything you can about that triangle. Okay, so what we have is we're going to need to find what? Yeah, we're going to need to find x, we're going to need to find y, and we're going to need to find z. Now, right off the bat, what's easy? Z, right? Why? Because I know that's 90, right? These other two must add up to be 90. So all I've got to do is take 90 minus 40, and that's going to tell me z is 50 degrees, correct? Now, this is where you got to start to pay attention. Now, in any of our trig ratios, like let's say I wanted to use cosine, and let's label these. Let's say I got big A, big B, and big C, right? And I set up any ratio. Like let's say I said, you know, the cosines. Let's say I said the cosine of big A. Well, what is cosine? Anybody remember? Adjacent over hypotenuse, right? So I would go adjacent over hypotenuse, right? So in any one of these trig ratios, I technically have three unknowns. Okay? I've got three unknowns. I've got the angle, and then I've got my two sides, right? Well, if you know anything about algebra, if I'm going to solve for something, how many unknowns can I have? I only have one, right? So I've got to know two of these values. Now, the reason I chose cosine, okay, is because if I use cosine, I've got my angle. That 40 is going to go right there, okay? And then I chose cosine because I have my what? Adjacent, which is going to go right there, and it's going to allow me to solve for my hypotenuse, right? So this is going to work out to be the cosine of 40 degrees is equal to 12 over, and in this case, my hypotenuse is the variable y. Now, kind of going back to, I believe it was Rusty's question here. My ultimate goal is to do what? Solve for y, right? Now, first off, what's wrong with y? It's in the denominator, right? And I don't want it in the denominator, I want it in the numerator. So what would I do? I'm going to multiply by y, so I'm going to times by y. Now when I do that, I always times it out front here. These two things are attached at the hip. They go together. You can't ever change them. It is the cosine of 40 degrees, which is just some other number. Your calculator will do that work for you, which is why it's important to have a calculator. Now, over here, my y's reduce out, right? And I'm going to get y cosine 40 degrees is equal to 12. Now, we want y, right? So that means I've got to get rid of what? The cosine of 40 degrees. So what am I going to do? Yeah, I'm going to divide by the cosine of 40 degrees, divide by the cosine of 40 degrees. They're going to go away, and I'm going to put that in my calculator. I'm going to go 12 divide cosine 40, enter. Divide cosine 40, enter. Now, everybody look at my calculator. Tell me what's wrong with that. Yeah.
Wait, I got 15.
Anybody else's calculator get what mine is?
Wait.
Okay, let me, there's a reason I did this, okay? So, Camp, she was a Johnny on the spot. What do you know is wrong with that?
How do you get something bigger than 12?
Well, it has to be bigger than 12, doesn't it? Because that's my hypotenuse. What do we know about my hypotenuse of a triangle? It has to be the biggest side, right? But I got a negative number out. Is that any way possible? No, we already said the other day you couldn't have a negative side of a triangle. So what happens is hit your mode key. All those that didn't get my answer. All those that got my answer. Now, notice right down here, fourth button down, Mine says radians. Can't be in radians. It's got to be in degrees. So arrow over and hit enter. Once your degrees is working, then just hit second quit. Then all you got to do is hit enter. And now, I'm guessing you all got 15.7. Yeah. It's because you're in the wrong mode. Okay? So we got y is 15.7. Now, as I get that answer, I need to do something that sophomores are terrible at. Okay? No. No, I mean, you're not great at that by any means, but you need to look at this answer and say to yourself, self, is there any way that answer is right? And you really can't guarantee that you're right, but you can guarantee that you're wrong, right? So if I got that number and it was less than 12, what would I automatically have known? Yeah, that it was wrong. Is that number bigger than 12? Yeah, so you're telling me I've got a chance. Right? Do you see what I'm saying? So kind of look at it that way, and I'm going to get 15.7. Okay? Now, we already got z is 50 degrees. Now I want to find x. Okay? What? I could, but
You rounded.
I did round, you're right.
And you don't know if it's for sure.
Exactly. So I never want to use, and there's going to be people do that, and that's fine. If I was, I was an arrogant teenager, I would probably do that too. But you don't need practice using the Pythagorean theorem. Okay? So what I'm going to do is I'm going to say, okay, sticking with what I was given, which was this and this, is there another one of these I can set up to find x?
12 and x and 90. What I guess
You'll never use the right angle.
Oh,
Sine?
no, 10.
Now if I use sine, sine is going to go x over that, isn't it? Again, that would have me use what? Something I figured out, and if it's wrong, no matter what, my next answer will also be wrong, right? I want to choose, or I want to try and use what was given. So is there a function that puts that, and that all together? Tangent, right? So I would say the tangent of my angle, which is 40 degrees, is equal to what?
X over 15 points. No, X over 12.
X over 12, right? Now, why is this one a little easier than what we had set up before? Yeah, because my x is already in my numerator, right? Yeah.
Remember that the y was on the denominator, so you times it on the thing, so then it canceled it out on the but then you have to times the other side of the equation by it to make it equal.
And then I had to divide that out to get it by itself, right?
Yeah. Okay. Sorry.
So right now, I'm just going to times by 12, and I'm going to times by 12, making sure I times this out where? Out front. These two reduce out, and I'm going to get x equals 12 tangent 40 degrees, and that's going to spit out what?
The number.
Very true.
10.1.
10.1? Anybody else get 10.1? Yeah, 10.1. Now, does anybody know something I can do to just look at that and see if I got a chance of being right? Yes.
You could do 10.1 square that added to 12 squared and just see if it's close.
Okay, I can see that, right? And it's not going to be perfect because we rounded. That's a great idea. Something even easier than that.
See if it's smaller than 12.
Okay, so Freestone's on the right track here. Why do I know that that has to be smaller than that? Yeah, what we already learned that we never trust. You never trust the picture. Hey,
Is Tristan Madden here?
yeah, she's right over there. Thank you. Thank you. Okay. Hess.
Because the degrees aren't the same on the
You're right. You're right. But does anybody know what that has to look like? No matter what, the smallest angle must correspond or be opposite from the smallest side. The biggest angle's got to be opposite the biggest side, and then the middle one's obviously the middle one, right? This angle's 40, that angle's 50. Do my sides work? Yeah, that side has to be smaller than that side. That's the biggest angle. Is the side across from it the biggest side? Yes. Okay? Let's do another one. Alrighty, so actually that's the wrong one. That's got to be 60. Check that. That's 60. Alrighty, so this is what we've got. Okay? Now, already, I know what? I know X is 30. X is 30 degrees. No matter what, it has to be 30 degrees, right? Now I need to set up some trig ratios that's going to allow me to solve for Y and Z, but I've got to use the 17, right? So what can I do that's going to let me do that? Cosine of big A?
Yeah.
But I know big A, and that's going to be 60, right? Cosine of 60 is what? What was cosine again? Adjacent hypotenuse, right? So it's going to be y over 17, right? Which is nice because, again, my variable is where? In the numerator, right? So what am I going to do? Multiply by 17, multiply by 17, they're gone. It's going to give me y equals 17 cosine 60 degrees, and that's going to give me what out? What? 8.5? 8.5? Okay, so that is 8.5. Does that logically make sense? Yeah. And if you think about it, it makes more sense in the fact that 8.5 is quite a bit less than 17, right? Well, my angle is quite a bit less than 90, right? Yes.
So if it is wrong, is it a problem on your end, or is it just a chance that it could, like, would that end up being?
Yeah, none of the ones we're going to do today or tomorrow or in the very near future are going to be possible. There are down the road some things you can do, but right now, you do the math right, you'll get the right answer. Okay? Now, so I've got that one. Now I got to find Z. So now what am I going to do?
Cosine of like 30 degrees equals 0 17.
Now again, could I do that?
Yes.
I could. What did I say though?
Don't.
Try to use what was given. Now, would I be okay with that being 30 and doing that? Yeah, because really, is there many mistakes I could have made there? No, but let's stay with the 60. What would I need to use now though? Sine. Why sine, Palmer? Because it's opposite what I know, right? So I'm going to go the sine of 60 is equal to what? Yeah, z over 17, right? And I'm just going to times by 17 times by 17. That's going to give me z equals 17 sine of 60 degrees. And that's going to give me what? 14.7. Does that make sense? Yes. Now, if I was doing this on a test, what would I do before I was finished? I would look. I might go far enough, especially, if we take this test this quarter, and I might need to do really well on it to get myself an A or something. I would probably even go all the way back and do what? I'd probably go Pythagorean theorem here just to check. And that would give me what? 8.5 squared plus 14.7 squared has to equal 17 squared, right? Now, it's probably not going to be what? Perfect because of the fact that we rounded, but it should get me close. 17 squared is
289.
289. I was off there. What do these two add up to be?
288.3.
288.3. We already said I was probably just going to be close. So we probably good here? Yes. Yeah. Okay. Alrighty. Now we're going to go raisey handy. Okay. Raisey handy, gamey. Okay, so you're going to need to find x degrees again. Well, can't have two x's on there. We'll have to make that a z. We're going to find our angle, we're going to find z, and we're going to find y.
Is this a right triangle?
Man, you keep ruining my joke.
Yeah, I was just about to put my pencil down and not there.
Yeah, I was going to see how many hands shot up in the air, but...
Me and Lily were just sitting here over here.
Yeah, they did.
Okay, so, do it. I want 10 hands. And I want you to find X, Y, and Z. One. Going for 10. Two. Three, 4. Again, write your numbers down if you have to so you don't forget them. 5, 6, 4 more. 7, 8, dos más, 9, uno más, 10. Alrighty, who was 3? Alrighty, Avery. What'd you find first? Found the X, and what'd you get for X? 63 degrees. Okay, we're good to there. How about, tell me how you set up Y.
I did the tangent of 10
So you did the tangent of 27 degrees equals what?
over y.
12 over y. Is she good to there? Okay, then what'd you do? Times by y, times by y. Divided by the tangent of 27. Okay, y's are gone, they're gone. So you got y equals 12, divide tangent of 27 degrees. And what'd you get? 23.6. So 23.6. Anybody else get 23.6? Okay. So you were 3. Who was 5? Okay, Murray, how'd you do z?
Well, I think I did it wrong. So.
Well, how did you do it?
Well, I did. Wait. I did cosine of 63 equals 12 over z.
Cosine, so you went the cosine of 63 equals 12 over z.
Yeah, and then I times it by z on each side. And then I got z equals 12 minus the cosine of 63.
Ah,
Yeah.
it's not 12 minus, it's 12. So you got to divide by the cosine of 63, right? So I'm going to get z equals 12, divide the cosine of 63. Now, can that be done that way? Yes. But you better be 100% sure that that value's right. Because if that's wrong, no matter whether you do it right or not, are you going to get the answer wrong? Yeah, so what do we get here for z? Anybody get it? 26.4. So we had, let's see, so we had 23.6 for here. We had 26.4 for there. And we had 63 for that. Do those numbers make sense? Did anybody Pythagorean theorem this to check? Not a soul? Let's do it. So I got 23.6 squared plus 12 squared equals 26.4 squared. What do my numbers end up being?
The 12 and the 23 is 700.96.
700.96. What's this?
696.96.
696.96. Am I probably close? Yeah, I would say you're probably close enough there. Okay. Alrighty, one more. Except we're going to go for 17 hands. Let's go big or go home, right?
Yeah. Yes, sir.
Yeah, it's not a very straight line, but we're going to pretend it's a beautiful triangle. Alrighty, I need, what did I say, 17 hands? 17 hands. One, two, three. Four. Okay, so 5, 6, 7, 8, 9, 10, 11, 6 more, 12, 13, 14, 3 more, 15, dos más, 16, uno más, 17. There we go. Alrighty, so who is 7? Alrighty, Lindley, what is Z? 53. What is X? 28.2.
Yeah.
And Y?
Y is 22.56.
22.56.
Sorry, X is actually 0.25.
0.25. It's going big right there. Anybody else get those numbers?
Is that 22.5?
Yeah.
Yeah.
22. 22. How many of you got those numbers? Raise your hands. Not enough. Let's go. All right, so Z should be obvious, right? Correct? Now, I'm going to use 37, correct? So the first thing I would do is I would say, well, the sine of 37 is 17 over x, right? Opposite over hypotenuse, isn't it? Well, times by x, divide by the sine of 37, divide by the sine of 37, right? That's going to give me x equals 17 divided by the sine of 37 degrees. Let's see what my calculator says. Clear that sucker out. 17 divide sine 37, enter. I get 28.247, which rounds up to 28.25. I would have probably went all the way to 28.3, but whatever. Right? Okay. And then for y, I would have said, now I'm going to use what? Tangent of 37 is opposite over adjacent. So I'm going to go the tangent of 37 is 17 over x, right? Times by x, divide by the tangent of 37.
Isn't it over?
What?
Shouldn't it be-
Sorry, it's over y, yes. Wrong variable. Gone. I'm going to get y equals 17 divided by the tangent of 37. I'm going to go 17 divide tangent 37 now, and I get 22.56, which I would say is about 22.6, just like that. What are we struggling with then?
I got it right.
You got it all right? Okay, those of you that didn't get it right, what are we struggling with? Yes.
Just the way you drew the triangle.
No, that's actually why I did that. Yeah, it is, and that's...
I went through and did all of the wrong math, and then I couldn't catch up and do all the right math.
Yeah, no, literally, that's why I chose that for the last one, is because, yeah, the way they draw it does make a difference. Now, the only other kind of problem you're going to run into that I think will be new is if I said this, if I said that the sine of theta was, let's say, 3 over 8, okay? Would you be able to tell me what the cosine of theta was and what the tangent of theta was? Just knowing those two numbers, that's it.
You could find half of
The X over 8.
Because you know,
Yo, Pikins.
Wouldn't you put them on a triangle and then do the Pythagorean?
I'm not gonna skip Bill's fist bump. That was perfect. That's exactly what I wanted to hear. Rule number 1 about right triangle trigonometry is to draw yourself a what? Draw yourself a picture, man. A picture's worth 1,000 words, man. Draw a picture. Draw a triangle. Now, where am I going to put theta?
I think you could put it.
Doesn't matter. It just can't be there. So if I put my theta right there, what does that tell me?
Hypotenuse is 8.
My hypotenuse is 8.
And the right
Angle on the right side is 3.
The right.
Say that loud. That's what I like. That I like how you said that. The what? No, Denzel.
Oh, the opposite.
Yeah, the side opposite my theta has to be a 3, right? Then I'm going to simply use the what? The Pythagorean theorem, right? And I'm going to go, it doesn't matter, let's just make it x. I'm going to go x squared plus 3 squared equals 8 squared, right? X squared plus 9 equals 64. X squared equals 55. X equals the square root of 55, right? So right now I got the square root of 55. Now, it wants the cosine of theta. Well, what's the cosine of theta going to be? So that's going to be the
Root 55 over
square root of 55 over 8, right? What is the tangent of theta going to be?
3 over. So that's
Put the 55.
Ah, you put that answer down, you're going to get it wrong. What's the real answer?
3 over 55 over 55.
What would I want to do here if I could? Simplify it. Can I simplify that? That's what it's going to want you to do. Okay? Alrighty, time is yours. Use it wisely.
How would you do it? How would you do it by hand? The cosine?
Well, first off, I would leave my mask up when I ask the question. How would I do it by what?
Like how we're doing, like how you have send out 60 degrees.
Sign, you sit in Vegas.
Sine of 60 degrees. How would you do that? Like, how would you do it by hand?
You mean, how would I find this angle?
Yeah.
That's not for today. But I will teach you that next time. Okay? Alrighty, people, let's get busy. Yeah, I thought about doing that, but I thought we're already 43 minutes in. There's no way we can cover more than one section.